This is 4.3. Pure math. Again, more derivatives. They gave you the curve here. Okay, they want to find the inflection point. Inflection point is when y prime prime or f prime 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 of x equals 0. So you have to derive this 2 times. So the first derivative, f prime of x, it's gonna be 2 6 20 20. Ha! Ya Allah. 3 times 4 is 12. Reduced by 1 it becomes x squared. And then 3 doesn't get derived. And the second derivative is going to be equal to 2 times 12, 24. X, we want to equate it to 0, so 24x equals 0. So x is going to be equal to 0. Question 2. Consider the curve. If this curve they gave you the curve. If the curve has exactly one local maximum, give the x coordinate of this local maximum. If it has no local maximum or more than one local maximum, enter 999. Okay, so let's see if it has maximum, minimum, whatever. Okay. To find the local stationary points, you always equate f prime of x to 0, right? Let's find f prime of x. Please, if you get it in a written part, you have to state f prime of x equals 0. This has 1 mark on it, okay? If you don't, you lose the mark. F prime of x is equal to what? 3 times 1 is 3, reduced by 1, x squared. 2 times minus 1 is minus 2, reduced by 1, it's x. 1 times minus 16 is minus 16. Reduce exponent 72 isn't a هيدا, right? F prime of x equated to 0. You can just factor this out. You're gonna get 8 over 3 and minus 2. Okay, so you're gonna get x equals minus 2, x equals 8 over 3. We need to determine which one is a stationary point, which one is a maximum, right? So you're gonna use either the second derivative or you're gonna use uh the شو اسمه, the table of sign. Honestly, for this one here, it looks like using the second derivative is easier. Just derive again. It's gonna be equal to 2 times 3, 6. Reduce x by 1 comes x. 1 times minus 2 is minus 2. Reduced by 1, mash v x. X and 16 doesn't get derived. So you get this is substitute your x values. If it's positive, it's a minimum. If it's negative, it's a maximum. 6 times minus 2 is it's minus 14, which is less than 0. Then 6 times 8 over 3 minus 2, it's you get 16, which is a positive number, right? So x equals 8 over 3 is a maximum, since it's greater than 0, is a minimum. If it's positive, like if it's greater than 0, like if y prime prime is positive at that number, then it's a minimum. If y prime prime is negative, then that point is a maximum. So is a maximum. What are they asking in the question? They're saying if it has exactly one maximum, then give the x coordinate of this maximum. We gave it. But if it has no local maximum, it has a local maximum. Enter 999. Okay, or more than one. It only has one local maximum, which is minus 2, right? Uh, this came in the CA, I remember. The function f is defined by f of x is equal to x squared plus 12x plus c. The roots of the equation are f of x equals 0 and minus r and minus 4. Okay. Honestly, when I was solving the exam, I found an easier way to do it than the way that I gave in the شو اسمه, in the earlier video. C over A, my product is C over A, sum is minus B over A. That's perfectly fine, by the way. But this one, هيك حبيت, since you're going to use it anyway for part C, I said if the roots are r and minus 4r, it can be rewritten as x minus r, x minus 4r, so it becomes plus 4r. So this actually is the same as this. If you expand this, you're going to get x squared 4rx minus rx minus 4r squared, which is the same as simplify it. So this is the same as this. So if you just equal them to each other, x squared cancels with the x squared. you're going to get 3rx is equal to 12. If 3rx is equal to 12, what's how do you find r? Sorry, is equal to 12x, sorry. So that means cancel x on both sides. You're going to get 3r equals 12, so you're going to get r equals 4. Right? Easy. And then we're trying to find minus 4r squared equals c. Right? So minus 4r squared equals c, meaning minus 4 times 4 squared equals c, so c equals minus 64. Very, very easy. This is a way you can easily do it by comparison. This is called by comparison. Okay, if you get this in a written part, okay. In factored form, what is it equal to? We said it's x minus r, x plus 4r, x minus r. R is 4, right? So you just substitute, and then 4r is 4 times 4, 16. Okay. The coordinates of the turning point are what? How do you find the stationary points of the turning points? You have to equate f prime of x to 0, صح? So let's find f prime of x. Let's أول شيء substitute. Or you see, it doesn't matter. If it's minus 64, it doesn't also get derived. This derivative is 0 of minus 64. 2 times x is, that's right, f prime of x is equal to 2 times 1 is 2x. Reduce it by 1, but here exponent 1. 1 times 12 is 12. Reduce it by 1, mash في x. Minus 64, doesn't have a derivative. Any constant number doesn't have a derivative. Equate this to 0. You're going to get minus 6. Take it to the other side. It becomes minus 6. So نحنا, we need the point, not only the y, not only the x coordinate. How do I find the y coordinate? I go up to my original one. And I substitute x. Don't substitute x in your derivative. No, substitute in the original point, right? So it's gonna be minus 6 squared plus 12 times 6 minus 64. You get 36 plus 72. Sorry, minus 72. This is minus 6 here. Alright, I'm substituting minus 6. Minus 64. And you should get minus 100. Question 4. You have, this is the function. The value, okay, this also came. The value of the gradient of g at the point where x equals 0 is how much? Okay, so أول شيء they want the slope at x equals 0. So let's find أول شيء. To find the slope at that point, you need to equate we have to substitute x into the derivative, right? That's how we find the gradient at a certain point. You have to substitute that point into the derivative. Let's find the derivative. Since there's more than one term under the power, we obviously need to use what rule? Chain rule, right? And the chain rule states that the derivative is equal to the derivative of the outside times the derivative of the inside, right? So let's see the chain rule. Derivative of the outside, 4x squared minus 2x minus 15 to the power of 3, because you reduce it by 1. Multiplied by the derivative of the inside, 2 times 1, 2x. 1 times minus 2 is minus 2, right? So you can just substitute 0, and you're going to get 27,000. Okay? Right. Function g has how many stationary points? Let me simplify this a bit so it's a bit easier. Obviously, you can't distribute the 4 into the cube because the cube is its own thing. So I'm going to distribute the 4 into the 2x minus 2. So it's going to become 8x minus 8, x squared minus 2x minus 15 cube. And since we're saying stationary points, what do we have to do? F prime of x is equal to 0. So I'm going to equate it to 0. صح؟ ماشي. This derivative equal to 0. That means either this equals 0 or either this equals 0. 8x minus 8 equals 0 gets you one solution, which is x equals 1. This x squared minus 2x minus 15 equals 0. You ignore the cube. We don't care about that. It's going to get you two solutions, and it's actually 1 minus 2 minus 15. You can get x equals 5, x equals minus 3. This question came in the CA, huh? And then they're saying which one is minimum, which one is maximum. So we got 3 points, so 3 station points. So part B is done, part A is done. I want to see which one's minimum, which one's maximum. How can you do this? You can choose more. We can use here the second derivative, or we can use the table of sign. Listen, look at your function. It's a bit long to derive it one more time. So let's use the table of sign. The table of sign, this is the first time I solve using the table of sign. I usually use the second derivatives. You put x, f prime of x, and the sign, whether it's increasing or decreasing. Let's see. In your x, you start with, if you get this in a written, and you decide to use, because sometimes they ask you, using the first derivative method, find the stationary points and determine whether they are local or minimum or local maximum. And sometimes they say using the second derivative test, find the stationary points and determine whether they are a local minimum or a local maximum. Depending on what they ask, you use. If they ask for second derivative, you use second derivative. If they ask for the first derivative, then you use the table of sign. So you put x f prime of x plus minus, and then you put, and that's too little. I need to make it a bit more spacious, between negative infinity and positive infinity. Then here, what are my x values? I have minus 3, 1, and I have 5. Obviously, at those points, f prime of x is equal to 0, and we don't care about the sign. Okay. We need to know now. Before minus 3, what's the sign? How do I figure that out? I check any point. Let's take minus 4, for example. Okay, any point, minus 4, and figure out its sign, f prime of x. How much is f prime of x at that point? Okay, you're going to see here. Let's substitute negative 4. It's going to be 8 times minus 4 minus 8 into minus 4 squared minus 2 times minus 4 minus 15 cubed. You get a negative answer, right? So it's going to be minus. So what's it going to be? You draw an arrow like this. Okay? You draw an arrow like this, going from left to right. Okay. Then, we need now a point between minus 3 and 1. The easiest point to take is 0. And they actually got at x equals 0, it's a positive answer. So we can just put it plus. And what does that mean? Increasing. Okay, then in between 1 and, let's take, for example, point 2. Okay, and substitute. Let's see. Quickly just change it to 2. You're going to get a negative answer as well. So that means minus, going down. And then after 5, you need to take a point. So let's take 6, for example. You're going to get a positive number. So it's going to be going up. When you get this table of sign, you're going to see minus 3 is a minimum. Why is it a minimum? Because it's a low point. 1 is a maximum. Why? Because it's a high point. 5 is a minimum because it's a low point, right? So we're going to say minus 3 and 5 are our minimums, and 1 is my maximum. Okay? Here they gave you the curve, and they want to know the maximum. Its value there is 13. Oh, okay. So they want your stationary points, maximum, minimum. So what you need to find f prime of x and equate it to 0. F prime of x is going to be equal to 3 times 1, 3, x reduced by 1 squared, 2 times minus 3, 6, reduced by 1, x. Okay, so we need to equate this to 0. So we're going to be x squared minus 6x equals 0. You can solve this very easily. Equals 0. So you're going to get x equals 0, x equals 2. Type. We need to know which one is a minimum, which one is a maximum. Okay, you can use the first derivative using table of sign, or you can use the second derivative. In my opinion, in this case, it's very easy to derive again, so I'm just gonna use the second derivative. 2 times 3 is 6. Reduced by 1 comes x. 1 times minus 6 is minus 6. So I can just substitute into this point and see if it's negative or positive. Obviously, when substitute 0, you get an answer that's less than 0. Hence, x equals 0 is a max. Local, you have to say local max. And then 6 times 2 minus 6 is greater than 0. Hence, x equals 2 is a local minimum, right? Type. So its minimum is at 2, its maximum is at 0. But they're asking for the value at x equals 0. So you just go here, you put 0 cubed minus 3 times 0 squared plus 13. And you get that its value is 13. Okay? question 6. Based on the above graph, which of the following is true about the what? Show unemployment. Unemployment from 1994 to 2015. Okay, obviously it decreased then increased. طب what 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 type of question is this? Okay, guys, just to show you how easy this question is, my brother's gonna explain it for you. Oh,
Hi
you see,
guys.
okay, you see this graph here?
Yeah.
What's true? Solve it. What's true about the level of unemployment
Okay. There.
from 1994 till 2015? What happened?
90. Like 1994 to 2015.
Yeah, what happened to unemployment?
So here's
Yeah, yeah,
1994, and then this is 2015.
yeah. What happened? What happened?
It decreased and increased.
Exactly.
Because look, it went. It's now first of all, it's now going down. Now in the middle point, it became up again.
So that means the derivative here, the slope, is it
Here.
negative or positive?
Here.
Yeah.
Here's it's negative because it's going down.
Okay.
And when it's going up, it's becoming positive.
Okay. Okay. Yeah, pretty much. If you get this wrong, you're a dumbass. Question 7. Okay, here you have this function. They want the inflection point. What is the inflection point? It's f prime prime of x equals 0. صح? So let's derive. The first derivative in this case will be 3x reduced by 1 squared, 2 times 12, 24, reduced by 1x, 1 times 1 is 36, minus 36, no more x, right? Second derivative, this is y prime. Y prime prime, derive again 6x because reduced by 1, 1 times 24, 24, and minus 36, not derived. Equate to 0, you're going to get minus 24, x equals minus 4. They want the y coordinate as well, so you take your 4 up here, and you just substitute. And so I don't think so, but I think 273 is gonna be correct. Okay, question 8. No, no, just no. Okay, yeah, guys. Anyway, uh, uh, over here they want the stationary point, so you just equate f prime of x equals 0. F prime of x in this case is gonna be 3x, not 3x squared. I mean, sorry, 6x squared. 3 times 2 is not 3. 2 times 3 6. It becomes x. 1 times 1 is 30. 1 is 36. 1 doesn't get derived, right? So stationary point, what do we do? We equate it to 0. You factor 6 out. You're gonna get, let's see. It's easily factorable, but يعني, let's see. You're gonna get 2 and minus 3. You're gonna ask the Walid, why did they take minus 3? Because they're saying the y is 82. If you substitute 2, you're gonna get, you're not gonna get 82. Okay, so you have to check your 2 points, substitute them here, and see which one gets you this y coordinate. Okay. Okay, consider the function here. What is true? Uh, uh, so they want to see which one's a saddle point and which one's a stationary point. A saddle point is just a stationary point, but when you draw the x f prime of x plus minus table, the table of sign, in between the two roots, let's say this is root 1, this is root 2, you'd have 0, of course, here, and then nothing here. Basically, it would be either increasing, meaning it's a saddle point. Like, for example, in the graph of x cube, it's both increasing here and increasing here. This is the graph of x cube. So basically, it's only a change in concavity here, which I don't know if that's required for the material. But it's a change in concavity. We'll see later on in this quiz if it's in the material. Basically, a saddle point is usually just for a change in concavity, not the change whether it's positive or negative slope. It can also be, by the way, decreasing. For example, in the graph of negative x cube, it's decreasing here and decreasing here, and the saddle point is here, huh? Okay, so let's see. 4x cubed minus 3x to the power 4. We're talking about stationary point and saddle points. So you're going to do f prime of x equals 0, صح؟ أول شيء let's find f prime of x. which is equal to 3 times 4, 12, reduced by 1 squared. 4 times minus 3 is minus 12x to the power of 3. Equate it to 0, so it's going to be minus 12x cubed. I like keeping the highest power as the leading term. Okay, equals 0. Minus 12 outside, you're going to get x cubed minus 1 equals 0. You're going to get x equals 1. Oh, sorry. Ish, hold up. What did I just do? Hold up. What the? You take minus 12x outside. No, minus 12x squared outside. You're gonna get x minus 1 equals 0. So you're gonna get either x equals 0 or you're gonna get x equals 1. Right? طيب. We need to know which one's stationary, which one's saddle. How do you do that? Table of signs, صح؟ بسرعة. x f prime of x plus minus. You're gonna get the two roots, 0, 1, 0, obviously at those two roots. Okay. And we need to know whether it's a saddle point, stationary point. So what do? You take a point before 0, suppose negative 1, and substitute it into your original function. So you're going to take 4 times negative 1 cube minus 3 power negative 1 to the power of 4 minus 7. So it's negative. So here it's negative, that means it's decreasing. Let's take a point after 0, but in between 0 and 1. So would be 0.5. And you're gonna get positive. Wait. My fault. You're supposed to substitute it into your derived function. Because you're trying to see the slope at that point. I don't know why I'm bugging. But anyway, substitute as, okay, negative 1. You don't write it, but like, okay. Always, by the way, for the table of sign, you're going to put negative infinity, positive infinity. Okay. So with negative 1, you substitute into your derived function always. It's negative 12, negative 1 squared, negative 1 minus 1. Positive. That means here it's positive. So it's going up. Then at 0.5, it's also positive. Then let's now take a point after 1. So let's take 2, for example. You get a negative. So that means after that is decreasing. So obviously, since 1 is the highest point, it's going to be a stationary point. And they're not asking if it's a maximum or minimum. But if they were to ask, then it would be maximum. But 0, it's both increasing in between the yani points. So it's a saddle point. Usually, cubic functions all have saddle points. Okay. Question. You have this function over here, and they want you to find the minimums and maximums using the second derivative, right? Type. Let's actually find the points and then derive again to check if it's a minimum or maximum. What do we find first? F prime of x, which is, let's derive 3 times 1, 3, and becomes x squared because reduced by 1. 2 times minus 6 minus 12, reduced by 1 x. 1 times 9 is 9, reduced by 1 mash x. Okay. Then f prime, sorry, shoo. You have to equate to find the stationary points. F prime of x to 0. Thus, 3x squared minus 12x plus 9 is equal to 0. I like factoring 3 out. Sorry, minus 4x plus 3. You're going to get two solutions. You're going to get x equals 3 and x equals 1. If I'm not wrong, let me just make sure. Yeah, 3 and 1. So you have these two, and you need to see if it's a minimum or a maximum using the second derivative test. What do? We do f prime of x, and you want to see if it's positive at that point or less or negative at that point. What is f prime of x? 2 times 3 6, reduced by 1x. 1 times minus 12 minus 12, 9 doesn't get derived. Let's see, at x equals 3. 6 times 3 minus 12, which is positive. So 3 is at x equals, sorry, x equals 3 is a minimum. Uh, at x equals 1, 6 times 1 minus 12, that's actually negative. So x equals 1 is a maximum. So you're going to choose this. It's a minimum because the second derivative at this point is positive, right? We found it's greater than 0. And this one's it's a maximum because the derivative at x equals 1 is it's negative. Akid, if you have written part, you need to find the y coordinate, but here you can solve it. And to save your time in computer, there is no need to do these pointless things, okay? Because you don't need them, you just need the x. So this function, they're saying this is the y, they want when is the maximum. So we need to first see the stationary points by equating it to 0, the f prime of x. How to find f prime of x is 3x squared minus 18x plus 24. And you need to equal this to 0. Take 3 out just to make your life a bit easier. Also, you're putting it in the calculator, it doesn't really matter. You should get 4 and 2. Let me just double check this. 5, 3, 1 minus 6, 8, 4, 2. Okay. So you need to, you can use, since it's easy to get the second derivative here, I'm gonna find the second derivative to determine whether it's a minimum or a maximum. Okay, so we need to see f prime prime of x if it's greater than 0 or less than 0. Let's see, f prime prime of 4. It's gonna be, we need to find, what's f prime prime of x before I even substitute. I should know what is f prime prime of x. 2 times 3 is 6, decreased by 1x, 1 times 1 is 18 minus 18, decreased by 1 minus 3x. You're gonna see, at 4, it's gonna be 6 times 4 minus 18, which is greater than 0. So that, what does that mean? X equals 4. Since it's positive, it's a local min. How about 2? It's less than 0 because you're going to 12 minus negative 6. So x equals 2 is a local max. So they want the y coordinates. So what do? You take the 2 and you substitute it into your original equation. 2 cubed minus 9 times 2 squared plus 24 times 2 plus 5. You should get 25. Okay. Question 12. Consider the function, okay? What is true? Uh, when okay, yeah, they just want to see the minimums and the maximums. So what do? We use or should we equate the derivative to 0, right? So let's find what's f prime of x. It's x cubed. It's 3. Sorry, take the 3 down. 3 times 1 3. Reduced by 1 x squared. 2 times minus 6 minus 12. Reduced by 1 is x. Uh, yeah, it's minus 12x. And 1 times 9 is plus 9. So you're gonna get this is f prime of x. We need to equate this to 0, right? So you're gonna get, let's put this in a calculator. ماني خلق صراحة to put it. Mod 5 3. You can get 3 minus 12 and 9. 3 and 1. So x equals 3, x equals 1. Let's see. We need to know if it's a minimum or maximum. So let's find f prime prime of x, which is equal to 2 times 3, 6, x minus 12. At 3, it's positive, so x equals 3 is a local minimum. F prime prime of 1 is equal to 6 times 1 minus 12, which is negative, so x equals 1 is a local max. Okay, so it's a minimum at x equals 3 and maximum at x equals 1. Of course, and they don't really care about the y, they're mainly asking about the x, whether it's a minimum or maximum. So if they ask you, obviously, if it was written, you need to find the full point x comma y. Okay. Question 13. Okay, consider the function dy over dx less than 0 when what? When greater than 0 when what? Equals 0 when what? Okay. X squared minus 4x plus 4. When is it less than 0? Okay. X squared minus 4x plus 4. remember when you're solving inequalities, you treat it as if the sign is an equal. If it's an equal, put it in your calculator, and you need to find what are the solutions. 1 minus 4, 4. So you get, it's a repeated root, so x equals 2 is the repeated root. Okay? So, okay, since you're squared, you have one solution. Uh, sorry. You have one solution where it's greater than. Uh, what am I saying, يا أخي؟ You have one solution uh, where it's greater than 2, right? And one solution where it's the same, less than 2. Usually it's the same, right? But we want the other solution, since you have square, it's plus minus, so it's also greater than. Okay, whenever you have square, one is greater, one is less than, but same answer. So one's at less than 0, one this. Oh, wait, no, 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 no. What am I saying? It's less than 0 for x less than 2, صح? And then greater than 0 for when x greater than 2. So you get what I mean? Because the solution is 2, so you just substitute x with 2. Let me re-explain. I explained it in a very bad way. X squared minus 4x plus 4. When is it less than 0? Less than 0 for x less than 2. How about x squared minus 4x plus 4? When is it? Oh my god! I'm saying. Ya Allah! They're saying dy over dx when I'm using y. Dy over dx is derivative of this, so I should have derived. Sorry. So it's gonna be 2x minus 4. When is it greater than 0? أكيد for x equals 2. I'm saying I'm doing something wrong, wallah. I mean, you solve this equation for the other side, 4 divided by 2, x greater than 2. And then this 2x minus 4. When is it less than 0? It's for x less than 2. So these are your two solutions. Okay, so it's less than 0 when this, greater than 0 when it's this. Okay, when does it equal 0? 2x minus 4 equals 0, so x equals 2. Okay, f attains a local what at what? Okay. If you want a trick, whenever you have when you ever have less than, or greater than, that means this point is a minimum, by the way. Okay, that's like it's a rule. Okay, but if you want to make sure, let's see here, 2x minus 4 is our dy over dx. To find it out, let's find the second. We know obviously when you equate your dy over dx to 0, you get x equal to, so 2 is a stationary point. We need to know if it's minimum or maximum. Let's see. Find the second derivative. We call d squared y over dx squared, by the way. 2x minus 4, derive it again. 1 times 2 is 2, minus 4 times 0, it doesn't get derived. So this is your second derivative is 2, which is greater than 0. It's always greater than 0. That means if it's greater than 0, x equals 2 is a minimum. How do you find the y coordinate? You substitute 2 here, comes 2 squared minus 4 times 2 plus 4. So you're going to get 0. Okay? Question 14. Okay. Uh, Here, again, same question. What's dy over dx? It's 2 times minus 1. It's minus 2x. Okay. And then 4 times, there's nothing, right? 4 doesn't get there. So this is your derivative, dy over dx. When is it less than 0? Let's see. When is it less than 0? Take minus 2 to the other side. It becomes greater than 0. 0 divided by minus 2 is 0. But since you divide by a negative number, remember, it changes sign, right? How about when is it greater than 0? Divide by minus 2, again, you're going to get 0, but since you divide by minus 2, it changes sign. Okay, so it's going to be, when it's less than, it's greater than. When it's greater than, it's less than, right? When it's equal to 0, okay, minus 2x equals 0, x equals 0. Or since you have, when it's opposite, when you have less than, greater than, and they're opposite, that means it's a maximum. Think about it like this, less than, greater than. You get what I mean? Okay. Uh, Wait, no, that doesn't make sense. That doesn't make any sense. What I just said now doesn't make sense. Anyway, forget about what I just said. Okay, this is just a rule. When you have less than, greater than, then it's always maximum. Anyway, to prove it, I can derive it for you one more time. The second derivative is 1 times minus 2 is minus 2, and خلاص, that's it. And this is always less than 0, so x equals minus 2. Oh, sorry, x equals 0. is a local max. And we need to know the y coordinate, so just substitute 0 up here, you get 4, obviously. That's it for this recording, guys. Thank you so much for watching. Good luck in your exam.